All right, let's do this problem called word pattern. Let's have a read. Given a pattern and a string s, find if s follows the same pattern. Now, what does this mean? It says here follow means a full match such that there is a bijection between a letter in pattern and a non-empty word in as. So let's look at an example and see what that essentially means. So here the pattern is A, B, B, A, and the string is dog, cat, cat, dog. So a letter has to match a non-empty word in string. So basically here A is corresponding to dog, okay, and B is corresponding to cat, and then again cat dog is BA, which is matching. Now here ABBA, that means there has to be a word, then another word, and then the reverse of and like the mirror image of that. So dog maps to A, cat maps to B, cat maps to B is correct, but fish is not mapping to A because dog maps to, that's why it's wrong. And similarly here it's AAA, that means it has to be the same four words again, right? So how do we do that? So essentially what we are trying to do is we are mapping every character in pattern to every character in the word. So in example of ABBA, so we had this ABBA and we had this cat. All right, we can use cat, dog, dog, cat as an example. So essentially what was happening was A mapped to cat, B mapped to dog, right? So ABBA was cat, dog, dog, cat, which was working out. In another example where you had the pattern as ABBA, but the string was dog, cat, cat, and fish. There you went through the patterns, so A and dog. So you you had this mapping that A means dog. Then next was B. That means it has to be a different word. So now you look at cat, right? So you assign this B maps to cat, and now you look at this B. B is something that already exists. So when B already exists, at that's the point you would want to check. So A does not exist, so A maps to dog. B exists, B does not exist, so B maps to cat. Now B already exists, so B is cat. So is it cat? Yes. And then A. So A already exists, which is dog. Is this dog? No. So that's why it fails. So we will create a hash map from a character to a word, and we'll use that to maybe solve the problem, right? So let's try and uh, come to the code and see if we can write a code corresponding to this logic of using a mapping between the letter in pattern and word in string. So we are using a hash map and using key as a character and the value is a string. So we use this. Now we're going to divide the string first into different, let's divide the string into different words, right? So let's try string split. If it doesn't work, then we'll use another way. But this is what is string as does not contain any leading or trailing spaces. As contains only lowercase English letters and spaces. Can there be multiple spaces? That's another problem, right? So I want to be able to split. So basically, I can try to use this. So I want to use this string split functionality in Java, right? So which is so let's look at the syntax of it. It's fine to search for that. So we go Java docs split, and let's quickly have a look at the official documentation about the split function. So it takes a regex and it gives an array of strings, right? So let's do this. So array of string and let's call it words equals to s dot split. A regex is and now we have to build a regex where regex would be space occurs X number of times. But essentially, if I take just a space like that, and if I do S, the problem is there are multiple spaces, then it would not break it correctly. Oh no. So even for multiple spaces, what it would do is it would not take an. So if there are multiple spaces, it might cause empty strings, and I maybe we'll just ignore empty strings. How about that? Yeah, but maybe I can update the regex um, for repeat, right? So could I do something where I do? Let's have a quick look at it. So uh, regex. Let's build a regex, and again, it's very basic. You have to just do a plus somewhere. So my guess is, could it be something as basic as so you go this, you give a space, and then you do a plus. Like is this well? Or maybe we'll see, right? So if you're thinking this is the work, so basically that means space occurs as many number of times as I want. Let's actually check this. So text and I'm testing, and now here I am going to do right. So yeah, so this is sort of working. Uh, you can divide the string across if as many consecutive spaces are there, that will be considered as a delimiter token, and it will divide the string with that. So that should be good. So now we have got words. Now what we're gonna do is for uh, let's go through the pattern. So one thing is if words dot length is not equal to the pattern length, then you can right away return false. Right, that's one thing. Now you're maintaining that they are same. So for each character, if one cases map contains key and other cases map does not contain key. In the case when map does not contain key, you're gonna just do map dot put character and the word of index plus plus. I can just do index plus plus here just for safety. So index plus plus, right? And now at the end of this, I'm going to return true. And if there's a problem, I'm going to return false from here. So this is where the map already contains the character. So you're gonna do if map dot uh, get of c, and you compare it with if this isn't equal to 0. I mean if they're not equal, then there is a problem, right? If there are no problems throughout, then you return true, and that's my code. Let's run. And incompatible types, string cannot be converted to int. Okay. So we already do s dot split. You don't need the other argument. And let's let's see what's the other compilation error is. Cannot find symbol. Which symbol here? Is it called compare to? I mean, I can also do equals, but let's first try this. Yeah, okay. So this works. So all three test cases pass. That's submit. And we got a wrong answer, unfortunately. Let's see for the wrong answer. So the pattern is A, B, B, A, and we get so this is also another thing. Okay. So, and this is a good one, right? So here what we had was A maps to dog, and then we saw B is not in the map. So we say, okay, we'll map B to dog, but dog already exists. So we might have to maintain two maps that, okay, like two-way mapping has to be there. So here dog already is present in the like because A there is a one-to-one mapping between A and dog. There's not a one-way mapping. So we add another map here, and that's so and this would be string to char rector, and let's call this char to word, and let's call this word to char. And this could actually also be a set, right? This could also be a set, I am guessing. I don't really need it. I just want to know whether this already exists. If it already exists, then it's a problem. If it's already exists, the word already exists, and it's not present in the mapping, then there is a problem, right? So I could also just use a set then. Fair enough. So let's use just a set, and let's not change the name. So here, when your map contains key, that means it was all good. The map already contains key. In the else case, also there is another corner case, which is um, if the so what it means is that there is no mapping from character to word, but this already exists. So if the word set dot if it contains this word, then why did the mapping not exist, right? Then there is a problem. The mapping should have existed. And if that's not the case, then already, so you add this mapping and you also add this word. Oops, words of index. All right, now let's run again first, and let's fix the compilation error. It's a basic one. All right, run again and submit, and it is accepted now. All right,